Welcome to Day 5 of the System Design Interview Guide. Today we're tackling one of the most debated topics in tech, SQL versus NoSQL databases. Knowing when to use which is absolutely critical in any system design interview. Let's kick things off with a really simple analogy. Think of SQL databases like a perfectly organized filing cabinet. Every drawer has a label. Every file follows the exact same format. Finding anything is super fast because everything is indexed and structured. But if you need to add a new field to every single file, that's a painful restructuring job. Now NoSQL is like cardboard boxes. You can throw anything in there, documents of different shapes, sticky notes, photos. It's flexible and fast to set up, but finding a specific item across all those boxes can be trickier. Let's get into the technical details now. SQL databases are built on ACID properties. These 4 properties guarantee that your data stays consistent and reliable, even when things go wrong. Here's what ACID stands for. Atomicity means a transaction is all or nothing. Think of a bank transfer. Both the debit and credit must succeed, or neither happens. Consistency means the database always moves from one valid state to another. Isolation means concurrent transactions don't interfere with each other. And durability means once a transaction is committed, it stays committed, even if the server crashes right after. Let's see ACID in action with a Java code example. This is a bank transfer using Spring's transactional annotation. Notice the select for update, which locks the rows to prevent race conditions. The key thing to tell your interviewer here isn't about the syntax. It's about understanding why you need these guarantees. The most popular SQL databases you should know are PostgreSQL, MySQL, Amazon Aurora, and Google Cloud Spanner. PostgreSQL is the go-to choice for most system design interviews because of its reliability and feature set. Now let's look at NoSQL. The first type is key-value stores, like Redis and DynamoDB. It's essentially a giant hash map. You store a value against a key and retrieve it with that same key. Dead simple and incredibly fast. Key-value stores are perfect for session storage, caching, leaderboards, and shopping carts. Basically any scenario where you need lightning-fast lookups by a single key. The second type of NoSQL is document stores, like MongoDB. Instead of rigid rows and columns, you store flexible JSON-like documents. Each document can have a completely different structure. This is great when your data doesn't fit neatly into tables. Document stores shine for content management systems, product catalogs, and user profiles. Basically anywhere your data has a natural document-like structure that could change over time. Third, we have wide column stores, like Cassandra and HBase. Think of these as rows with multiple column families. Each row can have different columns, and you can have billions of rows spread across many servers. Wide column stores are designed for time series data, IoT data, activity logs, and messaging systems. They excel at handling massive write volumes across distributed clusters. And finally, graph databases like Neo4j. These store data as nodes and relationships. You can see here how John is friends with Jane. Jane works at Google, and John likes a specific post. These relationships are first-class citizens, not afterthoughts. Graph databases are ideal for social networks, recommendation engines, and fraud detection. Anywhere the relationships between entities matter more than the entities themselves. Here's the decision matrix you should memorize for interviews. If your data has relationships and needs joins, go with SQL. If you need flexible schema or massive horizontal scaling, go NoSQL. If consistency is critical, like for payments, SQL is your answer. If you need blazing fast reads with simple lookups, NoSQL wins. In practice, many real systems use both. This is called polyglot persistence. Before we move on, let's talk about database indexing. This is something interviewers expect you to know. Without an index, the database has to scan every single row to find what you need. That's O of n. With an index, it jumps directly to the matching rows in O of log n time. The difference on a table with millions of rows is massive. Here's a concrete example. Without an index, searching for a user by email scans millions of rows and takes 500 milliseconds. After creating an index on the email column, the same query takes just 2 milliseconds. That's a 250x improvement from a single line of SQL. There are different types of indexes you should know about. B-tree indexes are the default and most common. They work great for range queries and sorting. Hash indexes are optimized for exact equality lookups. Full-text indexes are for searching through text content. And composite indexes cover multiple columns, which is especially powerful for common query patterns. One important tip: don't over-index your tables. Every index you add slows down your writes, because every insert and update has to update the index too. It's always a trade-off between read speed and write speed. Now let's talk about what to say in the interview. A great thing to say is, for the user profile data, I'd use PostgreSQL because we need ACID transactions for payment-related fields, and the data is highly relational. This shows you're making a data-driven decision, not just picking a database at random. Another strong answer: for the activity feed, I'd use Cassandra because it's write-heavy, time series data with no complex joins needed. This shows you understand different databases for different use cases within the same system. And for indexing, try saying, I'd add a composite index on user_ID and created_at for the messages table, since our primary query pattern is fetching recent messages for a user. This shows you think about actual query patterns, not just theoretical design. Now here's what to avoid. Never say you'd use MongoDB just because it's web scale without justifying why. Don't pick NoSQL just because it's trendy. SQL is often the better choice, and interviewers will push back if you can't justify your decision. Always discuss your indexing strategy when you bring up databases. And don't forget to consider whether your data needs ACID guarantees. Let's wrap up with the key takeaways. Make sure you know all 4 ACID properties with real examples. Understand the 4 types of NoSQL databases and when to use each one. Be ready to justify SQL versus NoSQL for any given scenario. And understand how indexing works and its trade-offs. Master these, and you'll handle any database question in your interview. And that wraps up Day 5 on SQL versus NoSQL databases. This is a foundational topic that'll come up in almost every system design interview. Review these concepts, practice explaining them, and I'll see you tomorrow for Day 6. Don't forget to like and subscribe.